In this video, we will be discussing about overlapping theory. Starting with the basic statement of overlapping theory, it says as half-filled orbital of valence shell having opposite spin overlaps to form covalent bond, and overlapping means common area sharing. From the statement of overlapping theory, it is clear that there are two conditions that govern the possibility of overlap to form covalent bond. The first condition being that the orbital should be half-filled, and the second condition is that the electrons in the two orbitals that is ready for overlap should be of opposite spin with respect to each other. Now let us do this question in order to understand in a more convincing way the statement of overlapping theory. In this question, basically we have to tell whether the overlapping to form covalent bond is possible or not, seeing whether the two conditions required for overlap are met. In the first part, let us name the spin of this electron as plus half, and in the b orbital also we see same orientation of electron like this, so we will give it a plus half spin as well. We see that the electrons in both the orbitals, that is a and b, are in the same spin, and so the second condition for overlap is not met, so we say that overlapping is not possible in this case, so this won't be the answer. In the b part, we see that this electron has got minus half spin, but in the b we have a fully filled orbital, so we see that the first condition is not met, so overlapping is not possible in case b. In the case c, we see that in a orbital electron has got plus half spin and b orbital electron has got minus half spin. We see that both the conditions are met, that is the orbitals are half filled and the electrons are having opposite spin with respect to each other, so overlapping is possible in case c. In the case d, we see that both electrons are having minus half spin, so overlap is not possible even in case d. So I hope the statement of overlapping theory is clear from this example. Now let us move over to a term here, that is internuclear axis. Internuclear axis is defined as the approaching axis of bond forming atoms, or axis on which nucleus of bond forming atoms is present. For example, we consider this overlapping. We see that bond is forming between A and B along the y-axis. So we say that whenever bond is forming between A and C, then the internuclear axis is y-axis, and if the bond is forming between A and B, then we say that the internuclear axis is x-axis. Next, let us look into some important points in overlapping theory. In the first part, we have to compare the sigma and pi bond. We know that sigma bond is formed by direct or coaxial overlap like this, and the pi bond is formed by lateral overlap like this. Similarly, we see here that this is the sigma bond and this is the pi bond, and sigma bond has a length say x here, and pi bond has a length say y here. So we clearly see that the length x, that is sigma bond, is less than pi bond. So we can say that attraction present in sigma bond is greater than that in pi bond, and the strength of sigma bond is greater than pi bond. In the second part, we have to see the size of orbital on the basis of the number of shell. In the first sub case, we see that we have 2p orbitals coaxially overlapping and the length is x. In the b part, we see 3p orbitals overlapping coaxially and the length is y. From the diagram also, we see that the length of 3p is greater than the length of 2p orbital. So x is less than y, and attraction when 2p and 2p interacts is greater than 3p and 3p interacts, because the length x is less than y. Attraction is greater than in 2p. 2p overlap means strength of 2p bond is greater than 3p bond. And finally, we can write this concluding point that strength is inversely proportional to the number of cells, because we see that when the cell number becomes 3, then the strength gets weaker comparatively when the cell number is 2. In the third point, we have to see the directional property, and we will restrict ourselves to the same cell. When the overlapping is between 2s orbital, we see that the electron sharing by one of the to 2s orbital is 33.33%. When the overlapping is between 2s and 2p, we see that the electron sharing by 2s is 33.33%, and the electron sharing by 2p is 100% when the overlapping is coaxial. Now when the coaxial overlapping is between 2p and 2p orbital, then we see that the contribution of electron density is 100% from both the orbitals, provided the overlap is coaxial. Concludingly, we can say that if electron density is greater, then the strength is greater, and 2s orbital is having least strength, and 2p orbital, the overlapping due to 2p orbital has maximum strength, and the overlapping between 2p orbital has intermediate strength. Now the fourth part, here we have to compare the strength of p-pi bonding, p-pi bonding, and d-pi bonding. We see that when the overlapping takes place, we have a length y and x and x. We see that in the d-pi bonding, both the length are x and x. In the p-pi bonding, we have x and y length. In the p-pi bonding, we have y and y length. And we quite clearly see that distance x is less than y, and we have 2x in d-pi. So the strength of d-pi should be maximum. In the p-pi we have 1x and 1y, so p-pi has an intermediate strength, and in p-pi bonding we have both the y, which is having a greater length. That means it has got less attraction, so p-pi has least strength. Now in the fifth point, we have to talk about delta and pi bond. We have to compare delta and pi bond. So when pi bond is formed, then we have coaxial overlapping, and the electrons shared by each of the orbital is 50%. And when we have delta bond, then we have 100% share of the electron density in the formation of bond. You can imagine the delta bond, the formation of the delta bond, as we have a cube here, and one of the face of cube, you just insert the orbital, you just stick the orbital on the face of this face of the cube, and the other orbital on this face of the cube, and overlap each other. Then you can imagine 100% overlap of electron density. So this was it. In next video we will look on to the types of overlapping.